Okay, so next up, we'll take a look at the domain and range. This is the last part of composite functions, and it can be a little confusing, but we're going to break it up and go over it piece by piece. Okay, so I want to start by taking a look at function machines. So you might remember function machines from algebra, where we take an input, plug in the input into the machine, and then we get an output. For composite functions, we can think of it as two different function machines where we take an input x, we plug it in to g, we get an output g of x, and then our next step is we need to plug in g of x into f, and then we end up with an output f of g of x. So really we're going through two functions, one after the other. Here, one note to make is we need to choose x values. We need x values where the outputs, in other words, the g of x values here, are in the domain of f of x. Because we need to make sure that when we output a g of x value, that it's a value that we could put into our f machine. If it's not in the domain, when we plug it into f, we're going to run into some issue. For example, if f is 1 over x, and we end up with a g of x value that's an output of 0, when we take 0 and plug it in to our f of x machine, we'll get an undefined value. 1 divided by 0 doesn't work out. So when we're looking at domain, we need to consider x values, not only that we can plug into g, but also that after we plug into g, give us an output that we can plug into f down here. So let's take a look at another diagram. I want to consider, let's first look at g of x. And we can think of the domain of g of x as some kind of blob of numbers. So over here, we have the domain of g of x. So all of the numbers inside of here, so think of this as just like filled up with numbers, are numbers that we can plug into g of x and we'll get an output that's defined. So here's our domain of g of x. When we perform g on this domain, so here this arrow is kind of like taking our numbers, plugging them into g, then we'll end up with a range of g of x. So over here, we have what we could call the range of g of x. So all of the values that when we plug in our numbers from our domain, all of the outputs that we get for g of x. So this is just for g of x. We have a domain, a set of numbers, and then when we plug them in, we end up with a range of g of x. A quick example would be if g of x is equal to, let's say, 1 over x. We could plug in, we know we could plug in 2, and then 2, when we apply g on it, will give us an output of 1/2. So 2 is in our domain of g of x, 1/2 is in our range of g of x. Okay, so that's an example of our domain, our range. All of the numbers, including these blobs, are in the domain, and then in the range, the outputs of g of x. Next, we want to consider, so we're composing g of x and f of x, so we're going to be taking some of these numbers here, we're going to plug them into f, and then we'll get an output. So we have the range of g of x. Our next step is to consider f of x. And we're going to take some values from g of x and plug them into f of x. So what we need to do is look at the range of g of x, identify which of these numbers, maybe there's this group of numbers here, is in our domain of f of x. So from the range of g of x, we need to identify which of these numbers can we plug into f. And then we'll take those numbers, we'll plug them in here. And then we'll end up with a range of f of x. So here we might end up with, here are all of the outputs from that yellow blob, the domain of f of x. Here we have the range of f of x. So for example, let's say that f of x is equal to square root of x. So square root of x, a number that could be in the domain of f of x, that's also in the range of g of x. So g of x, let's say we plug in 2. We plug in 2, we go to our range, we end up with 1/2, and then 1/2 is also in the domain of f of x. So 1/2 is also in our yellow section too. It's in both sections. So we can take 1/2, plug it into f, and then our output square root of 1/2 gives us, square root of 1/2 is our output range of f of x, which we'll just leave as square root of 1/2 because it's irrational. So square root of 1/2 is, as we can see, in the range of f of x, and more specifically, it's in the range of f of g of x. So one way to think of f of g of x is starting with our domain of g of x over here, and then taking those numbers, applying f of g of x. So we're plugging them into the composite function f of g of x, and then we skip all the way over to the range of f of x. And so this right here is our range of f of g of x. Let me write that somewhere we can see it. Range of f of g of x. So here we can think of this as our domain of f of g of x, and then this entire section is our range of f of g of x. So f of g of x is kind of like skipping that middle step and just plugging into the composite function and getting our outputs. So this diagram shows g of x. We could take our value, plug it in g of x first, get a range of g of x, and then from that range we can choose values that work with f, plug it in, and then end up with a range of f of x. So in this diagram, we see there are a couple of steps to go through when looking at the domain of g of x and the range of g of x. Let's consider these functions up here. G of x is 1 over x, and f of x is square root of x. And take a look at those specifically. So g of x is 1 over x, and f of x is square root of x. Okay. So we have our domain of g of x. We know that the domain of g of x is going to be all real numbers where x cannot be equal to 0. So we know we can't plug in 0 because we're dividing by 0. So this orange blob over here, we can think of the set of all real numbers, except 0 isn't included. So on the outside, maybe over here, set of all real numbers, and then we have 0 by itself outside of the domain. Okay, so we have our domain of g of x. We could then plug those values into g and look at our range of g of x. Range of g of x. And we're looking at 1 over x, so we know we can't end up with 0 because we can't take 1, divide it by a number, and get 0. So again, we have 0 on the outside here. But aside from 0, we can get any output. We get 1/2, we could get 100, we could get negative 100. All real numbers except for 0 is the range of g of x. So we have all real numbers. And I'm actually going to split this up into 2 sections. Let's split this up into, let's say down here we have positive real numbers, and then up here we have negative real numbers. So the big red blob is all real numbers, and then I just split it up. The top part, let's say all the negative ones. The bottom part is all of the positive ones. Okay, so that's g of x. Next, we're considering f of g of x, or f composed with g of x. So next, we're going to be taking some of these numbers from the range of g of x, and we're going to apply f to those numbers. And now it's important that we take a look at f of x and think about what is our domain of f of x. Well, f of x is square root of x, and if we want to stay in the real numbers, so let's not consider imaginary or complex numbers for now, let's just think real numbers. We know that we can't take the square root of a negative number and end up with a real number or a real output. So the domain of f of x, sticking with the real numbers, is going to be a set of all x values such that x is, we could also just specify x belonging to the real numbers such that x is greater than or equal to 0. So x has to be non-negative. So that means this entire top part is not going to work because it's not in our domain of f. So when we think about the domain of f, we can include all of these numbers in the red blob down here that are in the positive real numbers section. So here we have the domain of f of x. And one note to make here is notice 0, because we have an or equals to, 0 is in our domain of f, but 0 isn't in the range of g of x. So one note here is we actually don't have 0 as a value that we can plug into f, because we can't get an output of 0 in g of x. So 0 isn't actually included here, but we do have all of the real numbers that we could plug in. So anything from this yellow blob on the bottom here is in the domain of f of x. If we take all of these values and plug them into f, then we'll end up with our range of f of x. And these are all numbers, these are all positive numbers where we plug them into f and then we take the square root and that's our output. And then this entire thing, so the orange blob is our domain of g. And then whatever numbers we can plug into our orange blob, put into our red blob, fall into the yellow part, so our positive outputs, so that we can plug it into f. Whatever numbers we can do that with are going to be f of g of x. Numbers f composed with g of x. And so what we need to do is, looking back at the orange blob, we can only choose numbers. Only choose numbers that output to our yellow blob. In other words, output to the domain of f, or have outputs that are positive real numbers. So when we're looking at the domain of f of g of x, we need to make sure that the domain of g, we only choose the numbers where we'll get an output of g that works with f when we plug it into f. In other words, looking over here, if we have 1 over x, the only numbers that will give us a positive output for 1 over x or g of x are going to be positive numbers. So our domain of f composed with g of x is going to be real numbers such that x is greater than 0. And notice I included greater than and not equal to because 0 is not in our domain of g, so we can't include it in that white blob at the bottom there. So positive real numbers, when we plug it into g, they'll end up in this yellow section. We get a positive output, which is great because then we could take our numbers, plug them into f, and end up in the range of f of x. In other words, we can plug them into f and it'll work out. So this entire section here, this is our range of f composed with g of x. Okay, so a quick example is if we had, let's see, if we had, say, 2. So we know 2 is included in the white section. It's a positive number that gives us a positive output when we plug it into g of x. So if we have 2 and then we plug it in, then our output is going to be 1/2. And then we could take 1/2. It's a positive output, so we can plug it into f. If we plug it in, we end up with an output that is a square root of 1/2. So 2 is in our domain. and then 2 is also in our range. All right, so for now, we could find the range by considering the graphs, for example, or just thinking about the outputs. Our range in this case is going to be non-negative numbers, so any number above 0 is going to be included in our range. We'll usually just be talking about or finding the domain of f of g of x, though. So usually we just want to look at the domain of g, find values in that domain where if we put them through g, we get an output that works out with f of x, or is in the domain of f. Okay. So I know that was kind of long. I wanted to go into it in detail, though, and kind of like go through a diagram to show what's happening. We need to go through 2 separate steps when looking at domain and range when we compose functions. Okay, so let's take a look at an actual example from our textbook, page 151, example number 3. Here we're being asked to find the domain of f of g of x if f of x is 1 over x plus 2 and g of x is 4 over x minus 1. First, let's consider g of x and the domain of g of x. So first we're going to start off with g of x, domain. As we can see, g of x is 4 over x minus 1. So we know we can't divide by 0. We can't have an input that gives us 0 in the denominator. So we know what won't work is any x value where x minus 1 equals 0. So in other words, x equals 1 won't work. So for the g of x domain, we have x values where x is not equal to 1. Any other x value will work out in this case, though. So x values where x is not equal to 1. Okay, so that's g of x. Next, let's take a look at f of x, our f of x domain. So here, again, we have 1 over x plus 2. So we know that what won't work is any x value where we get 2 in our denominator. So x plus 2 equals 0. In other words, when x is negative 2, it won't work. So for our f of x domain, we have x values where x is not equal to negative 2. Okay, and now what we need to do is think about, so we can't plug in negative 2 into f of x. So we need to think about what x value, when we plug it into g of x, gives us an output that won't work in f of x. So what x value is not going to work out, because even though we can plug it into g of x, when we plug it into g of x, it's not in our domain of f of x. In other words, what x value, when we plug it into g of x, will give us negative 2. And whatever x value that is, that's not in our domain of the composite function, because our output isn't something we can plug into f. Because remember, here we have f of g of x, so if our output of g of x doesn't work in f, then we can't plug it in and get an output after we compose the functions. What x value gives us negative 2. Okay, so here what we can do is consider g of x. We have 4 over x minus 1, and we're trying to find what x value will give us an output of negative 2 here. So we can just solve for equals negative 2x plus 2. We subtract 2 from both sides. We have negative 2x equals 2. And we can see that x is equal to negative 1. So negative 1, if we plug it into g of x, we get negative 2, which we can't plug into f of x. So we know that negative 1 is not in the domain of f of g of x. In other words, so we know that x equals 1 doesn't work for g of x, so it's not in our domain. We also know that x equals negative 1. Although it works in g of x, our output can't be used in f of x, so it's also not in our domain. So to answer our question, find the domain. I'm going to scroll down a little bit. Our answer here is going to be the domain of f composed with g of x is set of x values such that x is not equal to 1, because it's not in our domain of g of x, and x is not equal to -1, because it works with g of x, but our output won't work with f of x. So here we went through a couple of steps, first looking at the domain of g of x, and then checking the range of g of x, and finding what values, when we plug into g of x, don't work for the domain of f of x. We need to go through a couple of steps when checking the domain and range for composite functions.